Hi, in today's video, we will explore the architecture of Grafana, providing a detailed overview of each component. We will take a closer look at Grafana's structure and functionality, offering insights into its high-level design. Grafana is an open-source platform for monitoring and observability designed to visualize and analyze metrics, logs, and other data from various sources in real time. It provides a flexible and intuitive interface for creating customizable dashboards, charts, and graphs, allowing users to gain insights into the performance of their systems, applications, and infrastructure. From a technical perspective, Grafana is a web-based application written in TypeScript and Go, with a backend that interacts with various data sources and a frontend that renders visualizations for users. I've got a diagram ready to walk us through the process. It's going to break down how Grafana operates and why it's so flexible for making custom changes. Okay, so let's start from the front-end part. Grafana's front-end is built using TypeScript and React. It provides a user-friendly interface for creating and managing dashboards, querying data, and configuring visualizations. The front-end communicates with the backend via RESTful APIs to fetch data and perform operations. Grafana also employs its own framework called Grafana Scenes for development. Grafana Scenes is a new front-end library that enables developers to create dashboard-like experiences, including querying and transformations, dynamic panel rendering, and time ranges directly within their Grafana application plugins that we have here. Application plugins in Grafana are extensions that allow users to add additional functionality and features to their Grafana instance. Unlike data source plugins or other panel plugins which are focused on data visualization and retrieval, app plugins typically provide broader functionality that enhances the overall Grafana experience. App plugins can add new pages, dashboards, visualizations, or administrative tools for Grafana. They can introduce new workflows, integrations with external services, or custom UI components tailored to specific use cases. Uh, Application plugins have two can have two parts. Its front-end part and backend part. The server-side code responsible for handling requests, performing business logic, and interacting with external systems or data sources. This backend code runs on the Grafana server and processes requests initiated by users or other components of the Grafana application. Front-end part of the plugin can use Grafana libraries to connect with features from Grafana main web application. When it comes to data source front-end plugins, users can connect Grafana to their data sources, create dashboards, and visualize data from multiple sources in a unified interface. This flexibility makes Grafana a versatile tool for monitoring and observability in various environments. Even if you have a super custom data source, you can write a plugin that accepts queries from Grafana frontend, communicates with the data source, transforms the retrieved data into format that Grafana understands, and then presents it for visualizations. Data source plugins in Grafana can be also backend based. They handle data retrieval and processing on the server side rather than directly from the frontend. Okay, so let's switch to the Grafana backend. Grafana's backend provides a variety of APIs for interacting with and managing different aspects of the Grafana application, such as data sources, plugins, dashboards, users, and access. User management refers to the functionality provided by Grafana server to manage users, roles, permissions, and authentication methods. This functionality allows administrators to control access to Grafana and its resources, as well as manage users' account and permissions. Okay, so let's move to another important part of Grafana, alerting. The alerting engine in Grafana is a powerful feature that allows users to create and manage alerts based on the data displayed in their dashboards. It enables users to define conditions and thresholds for specific metrics or data points and trigger notifications when those conditions are met. As per documentation of Grafana, it doesn't use Prometheus as its alert generator because Grafana alerting needs to work with many other data sources in addition to Prometheus. However, it does use Alert Manager as its alert receiver, but you can use other alert managers too. In Grafana, there are two types of alert rules: Grafana managed and data source managed. Data source managed rules are managed and evaluated by the data source itself, and Grafana managed rules are managed within Grafana itself and independent of any specific data source. If you are creating your own data source plugin, make sure it's a backend plugin, as Grafana Alerting requires this in order to be able to evaluate rules using the data source. Front-end data sources are not supported because the evaluation engine runs on the backend side. Okay, so let's summarize the architecture. Grafana consists of a front-end part, which can be extended within plugins such as data source front-end plugins, application plugins, and panel plugins. Grafana backend is a server-side component responsible for data processing, authentication, authorization, and serving requests for the front-end. It interacts with data sources, manages user sessions, and handles administrative tasks. Also, it can be extended by a backend part of plugin and by data source backend plugins. The alerting engine is responsible for creating and managing alerts based on predefined conditions. It evaluates data against alert rules and triggers notifications when conditions are met. That's pretty much it. Thanks for tuning in. I hope this overview gave you a good understanding of what Grafana is all about, especially if you are just getting started with the project. Keep exploring and don't hesitate to reach out if you have any questions. Happy monitoring!